Hi guys, welcome to High Score Online Tutorials. Today we're looking at a very common concept, common activity that occurs around us, that we take part in every day. See people taking part in it. We see it helping our everyday life. Talking about motion, talking about equations of linear motion. Before we continue, to follow us on our platforms, we are live on YouTube, High Score Online Science Tutorials, while on Facebook you are there at High Score Tutorials Online. Do well to check on those platforms for any update on tutorials that we dish out. On Facebook and on YouTube, don't forget to hit the subscribe button so you'll be able to follow up with whatever we do. Alright, talking about the word motion. Motion is an English word motion is a noun. It's a noun derived from a verb, to move. To move. And to move means to change position, to change location. So in physics, motion simply occurs when a body changes its location with respect to time. And don't forget, the only agent qualified to alter a motion, to start a motion, to alter it or to stop it is force. Force is the only agent that is qualified, that has the authority to change motion. Alright, so motion simply means change of position with respect to time. Now, if a body was somehow here, if at some other time it gets to this place, that means that what? Motion has occurred, and the space between this place and this place is our distance x. But sometimes we might be interested in knowing the direction of the motion. That's when a concept, displacement, comes in. Displacement. So displacement is just distance covered in a specified direction. That is, displacement is a vector, while distance is a scalar. Now, if you want to know how much time has been spent or how much distance has been covered per unit time, we talk about what? Speed. So speed, v, is equals to what? How much distance covered in meters per what time used in seconds. So speed is measured in what? Meter per seconds. Sometimes we are interested in knowing direction of the speed. So speed specified in the given direction is known as what? Velocity. Velocity. Look at it here. So velocity is equals to displacement over time. So distance is to speed. Distance is to speed what displacement is. So velocity. Yes. Distance, speed, displacement, velocity. Yep. Now, but sometimes, or if not most of the times, the speed or velocity is not steady. It changes. You see a guy driving car on a rough road, on a because of potholes. He's driving at a low speed, let's say 30 km per hour. And that gets to express. Boom, it fires the ignition, it starts moving at maybe doing up to 100 km per hour. That means there has been a change of velocity or change of speed. In that case, the guy has accelerated. He has increased his speed. He has changed the speed. So this change of speed or velocity with respect to time is what we call what? Acceleration. So acceleration is equals to change in speed or velocity over time. Okay. Change the speed. Let's assume the guy this is initial velocity or speed. Please, in this lecture, we're going to be using the two terms interchangeably. Speed or velocity, we mean the same thing in this concept. So This is our u, initial speed. This is our v. So acceleration will now be equals to what? Final v, and as initial u over time. Of course, in this case, we're going to have a positive number because this final speed is more than initial speed. But sometimes it's not like that. Sometimes there can be a decrease in speed. For example, when the guy suddenly wants to go down, someone wants to stop, what does he do? He applies the brake. The speed drops from 100 to 90 to 80 to 40 to 20, then to 0. That is, in that case, initial is because of initial, then the 0 becomes our final v. In that case, a becomes 0 minus whatever you have here, 100. In that case, you are going to have a negative number. In that case, the body is said to have decelerated or to have retarded. So deceleration or retardation is negative acceleration, which occurs when a body decreases its speed for a particular speed. So in our next video, we are going to be treating how the 4 motion equations are derived. The 4 equations of linear motions are going to be derived in our next video. Please keep watching. Before you leave, make sure you hit subscribe button. It doesn't cost anything. Just click on the subscribe button. You are good to go, so that whenever we draw videos, you'll be able to know that we have something for you. And I promise I can never ever fail you. I pray for you. Your velocity in life will never go down. You shall never experience any form of retardation. Acceleration will keep on being positive and positive and positive. Bye.